Hi friends, welcome to my another video. Today in this video, I will discuss the difference between circuit breaker and isolator. This is very obvious confusion because the circuit breaker and the isolator both are used for disconnecting or breaking the circuit. At one glance, you can see the isolator and the circuit breaker are exactly looking like same. But if you will know deeply about the circuit breaker and the isolator, then you will find that the isolator and the circuit breaker are quite different from each other. So here I have some circuit breakers. This is MCCB, this is air circuit breaker, and in my first slide I have shown you the MCB, that is miniature circuit breaker. In other side, I have shown you different types of isolator or disconnector. These type of isolator you will find in the substation or in high rating switch yards. And these type of isolators you will find in the LV sections like in the commercial building or in the residential building. Now let us try to understand in a simple way what is the difference between the circuit breaker and isolator. The first difference between the circuit breaker and isolators are circuit breaker is an on-load and off-load device, but the isolator is only an off-load device. What does it mean? Let me explain what is on-load condition and what is off-load condition. In order to understand this one, let us take an example. Suppose there is a load, in my case it is a heater, and there is one breaker which can be any type of breaker, MCB, MCCB, but it is a breaker. Okay, and this load is running, means there is a flow of current through this heater. In that situation, we can make this circuit breaker on and off when there was load running. That operation is called on-load operation, means when there is a flow of current through the load, we can make the circuit breaker off. And the other case is, suppose the load is not operational, so we can turn the breaker on to make the power supply available for the load. So what we observe from here, that we can operate the circuit breaker whether the load is running or it is off. When we operated the circuit breaker when the load was on, then it is called on-load operation, and when we operate the circuit breaker when the load was off, then we can say this is a off-load operation, meaning the circuit breaker can be operated at on-load and off-load condition. Now let us take another example with the same load, but instead of circuit breaker there is an isolator or disconnector. So the power supply is coming to the isolator, and through isolator it is going to the load. As I told you, in the circuit breaker case, we can operate the circuit breaker when the load is on, and we can operate the circuit breaker when the load is off. But in the case of isolator, we cannot operate the isolator when the load is running, when there is a current flowing through the load. We have to turn off the load by any other mean, and then we have to turn off the isolator. It means before turning off the isolator, before operating the isolator, we have to make sure that there is a no current flowing through the load, or in another way, we have to make sure that the load is not in the running condition. So that operation is called off-load operation. I hope you clearly understand the first difference between the circuit breaker and isolator is that the circuit breaker is an on-load and off-load device, but isolator is only an off-load device. The second difference between the circuit breaker and isolators is circuit breaker is operated automatically and manually. The isolator or disconnector are operated only manually. What does it mean? It means that if there is any problem occur in the load, then this circuit breaker can operate itself automatically, or we can go there and we can turn the circuit breaker off manually. So this circuit breaker will have a mechanism to operate itself automatically by sensing the problem in the circuit or in the load. But the isolator has no mechanism to operate itself automatically. In order to operate the isolator, we need to go near to the isolator to turn it off. But as I told you in my first case, before turning it off or on, we have to make sure that the current in the load is zero, or there is no load running at the time of operating the isolator. The third difference between the circuit breakers and isolators are circuit breaker is a protective device which disconnect the circuit in case of overload and short circuit fault condition. But the isolator or disconnector is just a simple switch which is only used for disconnecting the supply from the load. Let me elaborate this difference 3. In case of circuit breaker, suppose if there is a short circuit happened in the circuit, then this circuit breaker will sense this short circuit and it will trip itself in order to protect the load from the short circuit fault. In another case, suppose this load is taking high current more than its rated current, then this circuit breaker will sense this overload current which is taken by the load, and it will trip itself in order to protect the load from the overcurrent. So the circuit breaker is a protective device which is protecting the circuits as well as the load. But in case of isolator, the isolator, suppose there is a short circuit or there is a overload condition in the network, this isolator will not sense anything. And as I told you in the difference number 2 that it is not an automatic device, so it will not turn off automatically. So the function of the isolator here is to just isolate this load from the power supply source when this load is not in the running condition. Hope you understood what is the third difference between the circuit breaker and isolator. Circuit breaker is an protective device which is protecting the circuit as well as the load by disconnecting the power supply from the load. But in case of isolator, isolator will not sense any fault and it will not trip itself. But if we want to do any maintenance to this load, then this isolator will disconnect this load completely from the power supply in order to make the safe maintenance for this load. So hope you got the difference between the circuit breaker and isolator, that the circuit breaker is protecting the load and circuit, but isolator is not protecting the load and circuit. It's just providing a facility to disconnect the load from the power source in order to do maintenance or any other inspection works. The other difference is that the circuit breaker are coming in MCB type, MCCB type, air circuit breaker type, oil breaker type, SF6 breaker type, and the isolators are coming in pantograph type, knee type, double break type, center break type, earthing type. I will show you some of the example here. This circuit breaker is MCCB circuit breaker, that is the miniature circuit breaker. This circuit breaker is MCCB, that is the molded case circuit breaker, and this one is a air circuit breaker. Now let me show you the different types of isolator. This is double break type isolator because it's breaking from both the points, from this point and this point. This is a center break, this is breaking from the center, so this is a center break type isolator. This is a pantograph type isolator, and this one is a knee type isolator. Now let us move to the other difference between the circuit breakers and isolator. At on-load condition, the circuit breaker has high withstand capacity, but the isolator has low withstand capacity. The reason behind this one is very simple, because the circuit breaker is a on-load device. So during turning it on, the circuit breaker has to face a high current, and during off also the circuit breaker has to interrupt the high arc producing inside the circuit breaker. So it should have the high withstand capacity to handle this high current. But the isolator is operational when there is no load connected in the circuit, or we can say when the load is in the off position. So during operation, that is on and off, the isolator is not facing any high current at the time of on and at the time of turning off the isolator. So this isolator will have very low withstand capacity. Let us move to other difference, that is the difference number 6. Circuit breaker consists of an electromechanical switches and relay in a same box. But the isolator or disconnector is a type of simple mechanical switch. What does it mean? It means that when there is a overload current is passing through the circuit breaker, then the bimetallic strip of the circuit breaker will bend and it will trip the circuit. And if there is a short circuit current flowing through the circuit breaker, then this solenoid or the coil will pull the lever in order to break the circuit breaker. The motive of the whole discussion is that the circuit breaker contains the switches which is functioning as per the electrical supply characteristic. Means when the overload current is passing through the circuit breaker, then the circuit breaker itself trip it in order to protect the load from the overload current. And when there is a short circuit, then the circuit will trip itself in order to protect the circuit from the overload. But in the case of isolator have fixed contact and the moving contact. When we will rotate the handle of the isolator, then the moving contact make contact with the fixed contacts and it will complete the circuit. And when we will rotate the knob of the isolator in opposite direction, then the moving contact came into the original position and break the contacts with the fixed contact. So the isolator have very simple mechanism, but the circuit breaker has very complicated mechanism. So the isolator is only a mechanical switch, a simple mechanical switch which making and breaking the contacts. The other difference between the circuit breaker and isolator is the circuit breaker is costly and the isolator is cheap. Suppose if we are going to buy a circuit breaker of 630 ampere and a isolator of 630 ampere, then suppose if the circuit breaker rate is around 3000 dirham, then the same rating isolator you can get it only in 600 dirham. So there is multiple time difference in the price of circuit breaker and isolator if you are going to buy a same rating of circuit breaker and isolator. So isolator is much cheaper than the circuit breaker. The next difference between the circuit breakers and isolator is that the isolator or the disconnector can be used to reroute the power, but this facility can't be taken from the circuit breaker. That is, the circuit breaker can't be used to reroute the power supply, but the isolator can be used to reroute the power supply. Let me explain this one. Suppose here there is a two transformer 1 and transformer 2. Transformer 1 is a main transformer and transformer 2 is a standby transformer. At normal condition, this isolator is closed, this isolator is closed, and this isolator is open. So the power flow will be from here to this all loads. But suppose something happened to this transformer and we need maintenance, then what we will do, we will open this isolator and we will close this isolator. So the power flow will be from this transformer to all these loads. So the isolator is used also to reroute the power supply, but this function we cannot take it from the circuit breaker. Other difference between the circuit breaker and isolator is that the isolator can remove the trap charges, but the circuit breaker cannot be taken for this purpose. That is, the circuit breaker cannot remove the trap charges. Let me explain this one. Suppose this isolator is connected with this source, okay, and it is feeding this three-phase load. When the isolator was closed, then the power supply is coming from the source to the isolator and then to the load. But when we open the isolator, then the power supply will not come to the load, but there will be some trap charges in the load. And if someone will come to do any maintenance to the load, then that maintenance guy may get a shock from this trap charges. But what isolator exactly do is, when we open the isolator, then the moving contacts of the isolator will hit the earthing bars. Due to this, whatever trap charges is there in the load, it will release to the earth, and in that way the isolator release the trap charges from the load. Hope you got this concept. But this thing we cannot take from the circuit breaker. This facility we cannot take it from the circuit breaker. Let us move to the other difference between the circuit breaker and isolator. In circuit breaker, air, oil, vacuum or SF6 gas is used to arc quenching medium, but in isolator there is no any arc quenching facility. What does it mean? As I told you in my first difference of circuit breaker and isolator, that the circuit breaker is a on-load device and the isolator is a off-load device. Suppose this load is running, meaning there is current flowing through this load, and all of a sudden we turned off this circuit breaker. Then what will happen? The arc will produce between the moving and the fixed contact of the circuit breaker, as there was current flowing through the load and we all of a sudden trying to make this current zero. In that case, there will be arc produced between the fixed contact and the moving contact of the circuit breaker. So this circuit breaker arc need to be quenched as soon as possible. So the circuit breaker is using oil in the oil type circuit breaker, SF6 gas to quench this arc in the SF6 type circuit breaker, and air with the arc chute in the air circuit breaker in order to quench this arc, in order to kill this arc. Okay, but in case of isolator, we are operating the isolator, meaning we are turning it on and off when the load has zero current, means when the load is off. So when we will make the isolator turn on and turn off, the current is already zero. So whether we will change the position of the isolator, there will be no current, so there will be no concept, no reason of arc formation in the isolator. So there is no arc quenching medium also required, as there is no arc producing into the isolator. So that is the difference between the air circuit breaker and isolator, is that in the circuit breaker, oil, vacuum, SF6 gases are used to quench the arc produced in the circuit breaker, but in isolator there is no any quenching facility, as it is an off-load device, means there is no current in the load, then we are operating the isolator. So as there is no current, so there will be no arc, so there is not at all requirement of any arc quenching medium like oil, air or vacuum or SF6 inside the isolator. Hope you got the difference between air circuit breaker and isolator. Now let us move to the other difference. In circuit breaker, there is a chance of rise in over voltage during switching operation. In isolator, there is no over voltage rise during switching, as it is an offload device. The reason is same. As I told you, the circuit breaker can be turned on and off when there is a load running, but the isolator always be turned on and off when there is a load is off, load is not running. Before turning off to the circuit breaker, there was some finite value of the current. But when we turn off the circuit breaker, then all of a sudden the current value try to become zero, and due to that the voltage will rise. And we can say that during circuit breaker operation, the over voltage raise condition will occur, but as the isolator is a offload condition, so there will be no case of over voltage rise during switching off the isolator. Hope you got the difference between the circuit breaker and isolator. The other difference between the circuit breaker and isolator is earth switch are not included in the circuit breaker. Single or double earth switch are included in the disconnector. I explained you this point here, that how the earth connection can be made by the isolator when we will make it off. Now let us move to the other difference, that is the circuit breaker interrupt the normal as well as short circuit current during fault, but the isolator does not interrupt any current. As I told you here that the circuit breaker has some mechanism to interrupt the to sense the short circuit fault current and the overload current, and accordingly it will trip itself to protect the circuit and load. But the isolator do not have this mechanism. It has only the fixed contact and moving contact, which will only break and make the circuit at offload condition. So the circuit breaker can protect the circuit and the load from the short circuit and overload condition, and the isolator just only break the circuit and make the circuit at offload condition. So this is the difference. The last difference in the circuit breaker and the isolator is about the sequence of operation of circuit breaker and disconnector. Let me explain this one. Suppose there is a load and it is first connected with the isolator and then with the circuit breaker, and finally the circuit breaker is connected with the source. The first case here is that we need to on the load. In that time what we will do, we will first turn on the isolator. Why? Because there is no current flowing through the load, it is in the rest condition, it is not running. So first we will turn on the isolator, so it is a offload operation, and then we will turn on the circuit breaker. So the current will go from the circuit breaker to the isolator, because isolator is already on, then it will go to the load and load will function. Now the second case is we need to off this load. So what we will do, we will turn off the circuit breaker first, and as we turn off the circuit breaker, the current through the load will be zero. So then we need to turn off the isolator, as it is a offload device, so we are turning it when there is a zero current flowing through the load. Here you maybe have one question, that why we are using isolator here. Directly we can use the circuit breaker in order to turn on and turn off the load. There is no need of isolator. But no, you are wrong. There is a need of isolator. Why? This isolator will be close to the load, but this circuit breaker may be very far from the load. Okay, so during maintenance, first you will turn off the circuit breaker because this load was running. So you will first off the circuit breaker, then you will off the isolator. Okay, and you started the maintenance of your load. But suppose as the circuit breaker is very far from the load, so you cannot see that anyone is coming and turning on the circuit breaker. Suppose if anyone even on the circuit breaker, as your isolator is off, you will be safe. The other advantage of isolator is that when you will turn off the isolator, then if there will be any trap charges in the load, it will discharge, and when you are going to do any maintenance for the load, you will not get shocked due to this trap charges. There is the other advantage also to have an isolator. Here I showed a very simple circuit, but in practical situation, one circuit breaker feeding many loads. So Suppose if you have maintenance in some of the load, you will turn off the circuit breaker. After turning off the circuit breaker, you will turn off the isolator whose load need to be go under maintenance, and you will keep other isolators on. Then you will turn on the circuit breaker. In that case, the other connected load will not suffer, as you disconnected the load which need maintenance by the isolator. Suppose if there is no isolator for any of the load, then you need to turn off the circuit breaker, and until and unless you could not able to do the maintenance for the load, you could not be able to turn on the circuit breaker. In that case, the other load will suffer. Okay, hope you got the better understanding why we need the isolator even if we have the circuit breaker. I hope you find my video informative. I try to make this video as simple as possible in order to better understand the difference between the circuit breaker and isolator. If you really like my video, then please give thumbs up and subscribe to my channel. We will meet in any other informative video. Till then, take care, keep learning, and bye bye. Thank you so much.